Hey, guess what? You're not off the hook. It's the weekend. Well, we're just going to talk about a couple things that you probably don't know. Mutually exclusive events are things that cannot happen at the same time, like ride a car to school or ride the bus. You can't do both at the same time. So those are mutually exclusive events. And we could represent them with a Venn diagram. Event A, we use A and B's most of the time. Event A and Event B, there's no overlap there. A lot of students confuse mutually exclusive and independent events. Independent events are probability of one event does not affect the probability of the other. Okay, so that's a definition. So just show what independence, the idea of independence is, in a population, about 1 out of 7 people are left-handed. Okay, that's a statistic we can use. So if I calculated, that would be 5 out of 35 people. Now I collected your guys' data, and here's how many left-handers we had. We had 5, and there's 35 total students in the class that day. So 5 out of 35 is 1 out of 7. So if this is true, if the population, there's 1 out of 7 are left-handed, and in our sample, 1 out of 7 are left-handed, then the probability of being left-handed and the probability of being female are independent. Because that does not affect this. A does not affect B. The probability of A being left-handed is not affected by being female. Okay, so that's kind of hard to wrap your brain around. A lot of people think about dependence, like I'm dependent on my parents. You know, that's something different. We're only looking at the rules for probability. So I'm going to go through these things. If events are not independent, then they are dependent. So I'll talk about all those things here in a minute. So here's the data that we collected in class. We had 2 male left-handers and 3 female left-handers. So you know who you are. Totals, we can find the totals in each group. There's 15, 20, 30. I might as well put those up there. And your total should be 35. So we got a total of 35. So in order to calculate any probability, that's the number divided by the total amount. So the probability of being left-handed, we had 2 out of 35 left-handed. How many are female? We had 20 out of 35 females. So you can see that these, we call these actually marginal distributions. What's the probability of being left-handed or female? Okay, that's kind of tricky. You might think that we're going to add the two together and use the addition rule to add the two together, but we can't actually do that. So if you're going to use the addition rule, we say what's the probability of being left-handed or right-handed, but left-handed or female, two different things. I'll come back to that one in a little bit. That's a pretty tough one to think about. Just want you to think about it first. You could pause the video at any time to go ahead and answer all of these on your own. Then we'll come back to it. So I want to talk about the multiplication rule. The probability of A and B is the probability of A times the probability of B. We can just multiply them. So what's the probability of being left-handed and female? Well, we can use the multiplication rule. Or we can say, well, you know what? Isn't that being left-handed female? There's 3 left-handed females. So the probability of being left-handed and female is 3 out of 35. If the two events are independent, this means that the two events are independent, then we could use the multiplication rule. Let's see if it's true. The probability of left-handed female is supposed to be 3 out of 35. So the probability of being left-handed times probability of female. If we multiply those two together, we should make 3 out of 35. So let's multiply. Probability of being left-handed, there's 5 out of 35. Probability of being female, there are 20 females. There's more than that, but not everybody was in class. Daisy took off. So let's multiply. 20, or wait, that's 100 divided by 35 squared. Okay, that's not going to make 3 out of 35. That's way bigger than 3 out of 35. This is not true. Therefore, the events are not independent. They're dependent. Oh, hey, we got 2 multiplication rules. This is where it gets kind of tricky. Well, that multiplication rule is for dependent events. So these are dependent events. And I'm going to prove, well, basically I just proved that these events, being left-handed and female, are independent. Or, I'm sorry, are not independent. They are dependent. So probability of being left-handed and female equals probability of being left-handed times probability of, oh, that's a conditional probability. Probability of B given A, so B is female, A is left-handed. So I'm going to calculate these probabilities. Probability of being left-handed is right there, 5 out of 35. Probability of being female, given that they're left-handed. We're only talking about left-handers. Females, given that they're left-handed. We're not talking about any other group, so that's 3 out of 5. Probability of being left-handed and female, we already said that that's 3 out of 35. So let's do some crazy math here for you math people. Are these two equal? Yeah, they look equal. I just proved that the two events are dependent using the rules of probability. Cool. So my question would be, are these two equal? Is the probability of being left-handed given you're female equivalent to the probability of being female given that you're left-handed? A lot of students will think this symbol right here is division. Well, you can kind of think of it that way. Probability of being female given that you're left-handed. This is a conditional probability. Like before I said, these are marginal probabilities. 15 out of 35, 20 out of 35 are marginal probabilities. These are conditionals. Probability of left-handed given that you're female. Left-handed given that you're female. 3 out of 20. Left-handed given that, or female that you're given left-handed, 3 out of 5. Let that soak in for a minute. So we're only talking about which category, which are you given? That's the conditional. Hopefully you can read about it a little bit more. I have another example. Let's look at it. I also collected some data from you guys. We had our glass wearers. We had our contact wearers. We had our female glass wearers and contact wearers, and we had a bunch of people that were neither. So our male glass wearers, who's that? We had Leo and Hector, and who sits next to Hector? I forget. The addition rule. We're going to find the addition rule. The probability of A or B is equal to, we could just add the two together, and this is only if events are mutually exclusive. Mutually exclusive. So if they're not mutually exclusive, wow, which is that? If they're not mutually exclusive, then something else happens. So going back, we can take this idea, and what I want you guys to do, this is just a practice problem. Practice finding the probability. So taking that information that was collected, our data, calculate each of these probabilities. And the new ones would be this, the conditional probability. So this is good practice for you to go right here. Okay? Probability of male given that you wear glasses. We're only talking about glass wearers. So I'll give you the hint. We're going to divide by the total number of glass wearers, which is 10. Right here, we're going to divide by the total number of males. So we have to just count how many males there were. 15. So you got to figure out how many males there are.